This is Professor Belden. This is Trigonometry, Chapter 1, Section 3. This is Part 2 of the video. Okay, so now we have the identity set. These are the basic identity set. The course formula sheet will have all of them, but these are the basic ones we need early on, which are the reciprocal, the quotient, and the Pythagorean identities. The reciprocals we had used before, which is just reciprocating them. The quotient identities we used before, but we were defining them quite a little bit different because we were saying that tangent was sine over cosine, which we were defining as y over x, which is similar. And of course, since cotangents are reciprocal, it only makes sense that this is x over y. So the new ones being the Pythagorean identities, which are relying on the fact that the radius is 1, because essentially with the Pythagorean identity you have x squared plus y squared equals r squared, right? That's the formula for a circle. Or a squared plus b squared equals c squared if you use the ABC definition from geometry. It's not a very good a squared, is it? Alright, so we're just swapping out those x's and y's for sines and cosines, and we're swapping out the radius for 1. Okay, and I did the equivalents for tangent, secant, cotangent, and cosecant. So between all of those, you can figure out all of the trig values from a limited set. So for example, let's write the limited set here. So we want the sine, cosine, tangent, and the reciprocals, cosecant, secant, and cotangent. Okay, so we were given sine is 2/5, and we were given cosine is root 21 over 5. So using the reciprocal identities, which is the first ones, it says that cosecant and secant are reciprocals of sine and cosine. So we just have to flip those. Okay. Then we're using the ratio identities because it says that tangent is sine over cosine. So I have 2/5 over root 21 over 5. Cancel, cancel. So you have 2 over root 21. So and again, we're using the reciprocal identities. Cotangent is the reciprocal of tangent, so I have root 21 over 2. Okay. Pause the video. Find the remaining trig functions for the student problem. Okay, for the student problem, I have sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so the given ones were sine. Oh, that's not very good too at all. Let's try that again. Sine is 2/3. Cosine is root 5 over 3. So the tangent is the ratio of sine and cosine, which is 2/3 over 5/3, hence 2 over root 5. And these are all the reciprocal identities, so 3/2, 3 5/3, and 5 root 5/2. Okay. Alright, so the next one, we are only given one trig function, which is sine for 3/5, and I'm specifying it's an acute angle. So I don't need to worry about positives versus negatives. Since it's in the first quadrant, I only have to worry about it being positive. So let's write down our trig functions again. Sine, cosine, tangent, cosecant, secant. I probably should have left some more room, but oh well. Cotangent. So I was given the sine, which is 3/5, so I can use the ratio identity to get 5/3 here. So the other identities, tangent requires two functions, which I don't have. So I need to default to the Pythagorean identities. The Pythagorean identity says sine squared plus cosine squared equals 1. So sine is 3/5. Cosine we don't know. So we have 9/25 plus cosine squared. Let's see, we want that in terms of 25ths. That'd be what? 25/25. So if we subtract 9/25, cosine squared of theta equals, excuse me, 16/25. Okay, so we need to get rid of the squared because I don't want cosine squared, I want cosine. So I'm going to square root both sides. So that gives me a result of cosine of theta equals the square root of 16 is 4. The square root of 25 is 5. So I have 4/5. So now I can use the reciprocal identity to get secant, which is 5/4. And I can do sine over cosine to get the 3/4. And the reciprocal identity for cotangent and get 4/3. Okay, take a minute and do the student problem. Pause the video. Okay, student problem. We got sine, cosine, tangent. And we have what? Cosecant, secant, and cotangent. Alright, so secant is 4/3, so using the reciprocal identity, this must be 3/4. So I don't really have any more after that. So I have to use another Pythagorean theorem, basically. So if I go back up and look, there's several of them I can use, correct? Right? There's not just one. So whatever you have, you can go from. So if I scroll back up here, I have secant, 1 plus tangent squared equals secant squared, right? So I can use that one. Okay, so we'll use that one. Okay, so 1 plus tangent squared of theta equals secant squared of theta. So we have secant, which is what, 4/3? So if we square 4/3, it's going to give me tangent squared of theta equals 16 ninths, and this is going to be 9/9. So we're going to subtract 9/9 from that. So we have tangent squared of theta. Oh, that's not a very good equal, so let's get rid of that. And equals, that's a 9, right? So we have what, 7/9? Okay, we'll square root both sides. So that means our tangent, which we had over here, right? Tangent of theta equals root 7 over 3, because you can do the square root of 9, but not so much of the 7. So that means our cotangent of theta is the 3 over root 7 using the reciprocal identity. So we had the secant. That was 4/3. And we figured out the cosine from the reciprocal identity, which is 3/4. So now we can figure out sine, right? Because we know that tangent is sine over cosine. We have tangent, which is root 7 over 3. We don't have sine, let's call that x in the meantime. And cosine is 3/4. So I'll just multiply each side by 3/4. Cancels, 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 cancels. So that gives me root 7 over 4. Root 7 over 4, which makes sense, because now if you do sine over cosine, the 4's will cancel and give you the tangent. So that means our cosecant of theta, whatever angle that is 4 over root 7. Okay? All right. So there's more than one way to get to them. The point is, if you only have one trig function, you can find the other 5 using the trig identities. You don't need 2 of them now to get all of the answers like we did in the original problems. Okay. So next we have odd and even functions. There we go. Okay, so cosine and secant are, the reciprocals. So those are both even functions. And the reason that is if you think about it, if this quadrant is positive, positive, and this quadrant is positive, negative, whether I go theta in this direction or theta in this direction, I'm going to get a positive answer for cosine. If I go far enough to make it to this quadrant, that's the negative, negative quadrant, cosine is now negative, correct? And if I go far enough to this quadrant, it's the negative, positive, cosine's now still negative. So either way, whichever direction I go, I'm going to get the same answers of the same value. So you can just drop the negatives from cosine and secant. All the other functions, that's not true, because sine is positive in this quadrant. If I go the other way, it's going to be negative. So I cannot just simply get rid of the negative in the odd function cases. What I need to do is just put it on the outside, because it's the same answer as far as the coordinates on the circle. The only difference is it a positive or negative outcome. So not worrying about which direction to spin in the circle, just get rid of the negatives. Okay, so this requires you to know your unit circle to be able to answer these questions. Nope, I went too far. Sorry, my scrolling is not working well on my mouse. Okay, so cosine of 45, since cosine is an even function, I can just get rid of the negative altogether. So I have the cosine of 45 degrees, and we know that the 45-degree angle, right, which is our pi over 4, is this coordinate, which is root 2 over 2, comma, root 2 over 2. That's our cosine, that's our sine. So our answer is root 2 over 2 for the ratios of the sides, given the angle of 45 degrees. Okay, tangent is an odd function, therefore we have to take the negative out. We cannot just simply get rid of it like the even functions. And we get negative tangent of pi over 3. So we do our unit circle. Pi over 3 is 60 degrees. Right? Okay, so we have what? 1/2 root 3 over 2. So that's cosine comma sine. But wait a minute, we want tangent. But isn't tangent, using our identities, sine over cosine? Right, so we have root 3 over 2 over 1/2. So I end up having root 3 over 1 when we cancel, but I still have that negative on there I have to worry about, right? So I have negative root 3 over 1, or just simply negative root 3 if you did it on a calculator. Although the calculator is not going to give you root 3, they'll give you the decimals that go on forever, because it's irrational, of course. Alright, pause the video, try the student problem for yourself. Okay, secant is an even function, because it's cosine's buddy, right? Reciprocal buddy. So I can just get rid of the negative. So if I do 60 degrees, right? We just did 60 degrees, didn't we? Okay, that's the pi over 3, which is 1/2 comma root 3 over 2, which is their cosine comma sine. Right? But we don't want cosine or sine, we want secant. But isn't secant the reciprocal of cosine? So instead of 1/2, I get 2 over 1, or simply just 2. Okay? Alright, next one. Sine of negative pi over 6, which is an odd function, so I have to take the negative out. Okay, so pi over 6 is 30 degrees. And that coordinate is root 3 over 2 comma 1/2. Cosine comma sine, so the sine is 1/2. But I have a negative on the outside, so the answer is negative 1/2. Okay, so that's a way of dealing with the negatives and just making them all the first quadrant to make it easier for you. Not worth to worry about it till after. Okay, so next set of problems. Determine the exact value for each of the 6 trig functions given the corresponding arc is pi over 4. So the arc is pi over 4, which means the angle is also pi over 4. Obviously, they will not give you diagrams in the textbook problems, so you'll have to draw them for yourself if need be. So remember that the arc length equals r times theta, but r is 1, right? Because this is a unit circle. So the arc length is equal to the angle. as we had specified, so don't have to worry about that. So remember, if it's a pi over 4, it's a 45-degree angle. That's root 2 over 2, comma root 2 over 2, which is the unit circle value for our cosine sine of that coordinate. So sine over cosine, or root 2 over 2, root 2 over 2. You can reciprocate to get the cosecant and secant values. Tangent is sine over cosine, but that's just 1, right? Anything over itself. If you want to make it a fraction, 1 over 1, so you reciprocate that to get 1 over 1 for cotangent. All right, pause the video. Try the student problem. Okay, so for the student problem, we were given pi over 6 for the arc length, right? So pi over 6 is the arc length, which means pi over 6 is the angle. So therefore, this coordinate is the coordinate if I was doing 30 degrees from the unit circle, which is the root 3 over 2 comma 1/2, which is our cosine and sine values for x and y. So that's 1/2 for sine, root 3 over 2 for cosine, so 2 over 1 for cosecant, 2 over root 3 for secant. And if I do sine over cosine, I get 1 over root 3 for tangent. To the reciprocal identity, I get root 3 over 1 for cotangent. Okay? All right, let's try the last page. All right, periodic function. Okay, periodic function means it periodically repeats itself. That's essentially what it means, like you have periods in a day in school. So we want to repeat it for the smallest value possible. So for sine and cosine, it's every 2 pi. Okay, and we're going to leave out the secant, cosecant, and cotangent because it's the same thing basically, the reciprocals. So if you go around the circle, right, no matter where you are on the circle, right, if you go around 360, which is 2 pi, you're back to the same place, correct? You get the same exact answer. For tangent and cotangent, that's not what we're going to use. We're going to use pi, right? And the reason being is, if you think about it, this quadrant is positive, positive. This quadrant is negative, negative. Tangent is sine over cosine. Positive, positive, and negative, negative both give me a positive outcome, don't we? And if I'm in the other quadrants, that's negative, positive, positive, negative, I'm either going to get negative over positive, or I'm going to get positive over negative. Either way, the outcome's negative. So if I have something over here or here, it's the same answer for tangent. I have something here or here, it's the same answer for tangent or cotangent. Okay? So essentially, every pi around the circle is the same answer for tangent, cotangent, right? Everything else, sine, cosines, are 2 pi. You have to go all the way around. Okay, so the point is, I don't want to do angles that are ridiculously high, like 9,900, 800, 420, or 600 pi over 3 or something like that. I don't want to do that. I want to do the smallest angle possible, which is the same answer, because I can equate those quickly. Because I don't want to have to draw them and figure out how many times I need to go around the circle and where I end up. That's obnoxious. So here I'm going to subtract 360, which is the period of a cosine. So cosine, let's see, that gives me 40 more 20, 60 degrees. Okay, so this and this are the same answer. So I don't need to do 420, I can do 60. So if I know my 60-degree angle, which is this one right here, right, which is pi over 3, that angle is 1/2 root 3 over 2 for the coordinate for our cosine sine. So my answer for this is 1/2, which means the answer for this is also 1/2, since it's the same answer, right? Because if I went all the way around 420, I'm in the same place. Okay, so sine of 9 pi over 4, if you think about it, 2 pi in this case, if it's in terms of fourths, is how many fourths? Think about it. 8 fourths, isn't it? That's 2 pi. So if I subtract 8 fourths pi, I get the sine of 1 pi over 4, right? You don't really need the 1, but you can put it there if you want. So if I do that, pi over 4, that's a 45-degree angle, which is a root 2 over 2, root 2 over 2 coordinate on the unit circle. So cosine sine, my answer for this is root 2 over 2. Let's get rid of that 1 since we don't need it. Which means it's the same answer for this one, which is root 2 over 2 for the ratios of the sides. Right? Because I could go all the way around, right? Which is 9 pi over 4, but that's obnoxious. We only need to go this little bit right here. Okay, last one. This one's going to use the odd and even rules, and it's going to use our periodic rules. So here, we can just put the negative on the outside, because it's an odd function, so I don't need to worry about which direction I'm going. And then tangent repeats every pi. Pi in this case is 4 pi over 4. So I can take out a 4 pi over 4. So I'm left with negative tangent of pi over 4. Okay. So we just did pi over 4 a second ago. That's right here. Okay. So if I think about it, tangent is sine over cosine. So root 2 over 2 over root 2 over 2 is sine over cosine. Well, that's anything over itself is 1, right? So that's a 1. So that's a negative 1 as an answer. So this is negative 1 as an answer, which means this is also negative 1 as an answer. Okay? All right, pause the video. Try the student problems for yourself. Okay, 405 degrees. I really don't want to do that. So I'm going to subtract out the period of 360 degrees. So that gives me the cosine of 45 degrees, which is the same answer. And 45 degrees is the coordinate of root 2 over 2, comma root 2 over 2 for our cosine and sine values. So this is root 2 over 2, which means this is also root 2 over 2. If I went all the way, so that's 45 degrees. If I went all the way around and did 405 degrees, which is not necessary. Okay? They will give you some problems that are in thousands of degrees or whatnot, obviously in the text. So here I don't want to do 7 pi over 3. So 2 pi, which is the period, which is 360, is how many thirds? That's 6 thirds, correct? So I'm going to subtract 6 thirds. So I get sine of pi over 3 is the equivalent problem. Pi over 3 is 60 degrees. Pi over 3, which is 1/2, comma root 3 over 2 for the coordinate for cosine, comma sine. So we want sine, so that's a root 3 over 2 for this answer, which means this answer is also root 3 over 2. So if I went this much, that's pi over 3. If I went all the way around, that's 7 pi over 3. Okay, last one, cotangent. I should have thrown a negative in here, but I guess I didn't. So I need to subtract out iterations or periods of pi, which in this case, if it's in terms of fourths, is 4/4. So if I subtract 4/4, the cotangent is pi over 4. We already did pi over 4 over here. That's 45 degrees, isn't it? 45 degrees is pi over 4. So if I do cosine over sine, I get 1, which means this is also 1. Okay, that is the end of part 2.